Hey guys, here with 1-2 patterns and functions. This is a we do video, which is helping to explain this worksheet, which you should have done yesterday or the last time that we had class. So this is just explaining how you get the correct answer for each one of these problems, and then hopefully we'll prepare you for our quiz or the you do section of this lesson. So let's jump right into it. We are writing a function rule for the table to the right. And let's take a second to kind of study that table. So the first column is number of cans of frozen orange juice. Okay, so we're talking about cans of orange juice. And then the second column is actually what the total cost is. Okay, so you can see some different money values there. But remember, just to kind of review a couple things we talked about previously, one of these columns is going to be our x value, which is also called our input value, the number that we input into the function. And then the other column is going to be the y value, also known as the output value. So based on what number is plugged in for x, that is going to directly affect the y value, or how much it's going to cost. So let's see if we can figure this out. So the x column, or the input, is cans of orange juice, and notice it just goes up 1, 2, 3, 4 cans. But with each number of cans, see that the y value starts off at $1.25, then goes from $1.25 to $2.50, and from $2.50 to $3.75, and I can quickly notice that it seems to be going up an even $1.25 per can of orange juice. Okay, now if you don't see that yourself, remember one of the strategies I gave you in a previous video is take the total and subtract it from the total before, and that will give you the difference. So for example, if you took this $2.50 and subtracted it from $1.25, I'm just going to do this math quick. So we can't do 0 minus 5, so we need to borrow from the next number over. That becomes a 4. This becomes a 10. 10 minus 5 is 5. 4 minus 2 is 2. And let's not forget our decimal. Throw our decimal in there. And then 2 minus 1 is 1. So just as I suspected, the difference, or the jump from one column to the next, or from one y input to the next, is $1.25. So I'm going to write that in here. 1.25 is kind of the change that we see in the y column. Okay, now we need to plug in our x and y. Okay, so the way we figure this out is 125 times the number of cans of orange juice, which is why we're going to put an x, times that is going to equal the y value. Okay, so for example, if we take $1.25 times x, and let's say that x is 2, $1.25 times 2 is going to be $2.50. So I'm just going to write it out here. So 125 times 2 equals 250. So that works. Let me erase and show another one and see if our function rule works. Let's try this one right here. So let's say it's $1.25 for a can of orange juice, but your x value up here, we actually bought 3 cans of orange juice. 125 or $1.25 times 3 works out to be $3.75. Okay, so I think our function rule that we wrote here works perfectly. Moving on. The next one, cans of soup is going to be our X, or our input value, and number of servings is going to be our Y value, or our output. Okay, so I notice here your cans of soup goes up 1, 2, 3, 4. But with each can of soup, the number of servings seems to go up by 4. Right? From 4 to 8 is 4. From 8 to 12 is 4. And from 12 to 16 is also 4. So I think our trend and the way we can start our function rule is to put a 4. All right? Now, very similar to what we wrote above, 4, we're going to multiply 4 by X, or the number of cans of soup, will equal your Y, your number of servings. Okay? So 4 times the number of cans of soup will equal your Y, or the number of servings. So let's test it out. Let's, I'm not going to do all of these, but let's just plug in, let's say this one here. Let's try our function rule out and see if it matches what I just surrounded in blue over there, or excuse me, in green over there. So 4 times X, in this case, is 4. So 4 times 4 cans of soup, 4 times 4 is going to give me 16 servings. So if you have 4 cans of soup and you're multiplying that by 4, the number of servings is going to be 16. Now you could plug in this number of cans, this number of cans, and this number of cans, and it will every time equal what's in this column, because this is a true function. Okay. Let me scroll down once, and we are going to finish. Sorry, let me extend this page if it'll let me. There we go. Okay, so this one's a little bit trickier, but that's okay. We're going to walk through it. So we have time in number of hours, which is going to be our X value, or our input. And then we have the cost of bike rental. And we see here that it's 10, 16, 22, and 28. But that's going to be our Y. Okay, so what I would do is we notice time in hours just goes up 1, 2, 3, 4, but on the left column, but on the right column, the cost of the bike, it goes from 10 to 16 to 22 to 28. Now, me just eyeballing this, I noticed that from 10 to 16, we're adding 6. From 16 to 22, it goes up another 6. And from 22 to 28, it goes up another 6. So I think that my function rule needs to begin with a 6, right? Now 6, so we're going to start with 6. I think we're going to have to go 6x, or 6 times x, because we're going to need to plug in the input value, or time, in hours, which could be this one, this one, this one, or this one, any of those x's. But the reason why this one's a little bit trickier is that we can't just do 6x equals y. And the reason being is that we didn't start off with a 6. We actually started off with $10. Okay? So going from 0 to 10 is different than starting off, or going from 0 to 6. Okay? So what we need to do is we need to figure out the difference, or where it started from. So we're going up by 6, but we started at 10. So we got to figure out what number we need to add to our function rule. Okay, so 10 minus 6, which again, we shouldn't start at 10 up here. It should start at 6, but instead it starts at 10, which means there's 4 extra dollars in there that we need to account for. So we cannot do this, 6x equals y. Instead, we need to do this. We're going to continue to go with 6 because that's the pattern that we saw over on the right. We're going to do 6 times x because that's our x, or time in hours. But the thing that we're going to throw in there is this plus 4. Okay? It started at 10 over here instead of starting at 6, and we need to account for that. So 6x plus 4 equals y. Okay? Just to show this one more time that it works, let's just go through this one. Let's plug in 2 hours and see if we get this 16 over here. So if we recognize that the pattern was 6 in the y count column, we're going to multiply 6 times the number of hours, and we're going to do 2 hours. So 6 times 2. But we're also going to plug in this plus 4 because of the difference between 10 and 6 that we talked about a second ago equals y. Okay, so again, order of operations, let's not forget that. We're going to do 6 times 2, which is 12. 12 plus 4, which is 16, is our y value. So if you do 2 hours, you plug it into our function rule, it's going to equal 16. Okay, I hope that makes sense, and thank you for watching.